All right, here we go with more of this Algebra 2, chapters 1 through 3, review. And now we are in part 5. I think we're probably going to have about 7 parts to this, but each one's, about 7 or 8 minutes. It's only about an hour, hour and a half of work here. So it says find the slope of the line that passes through the points -3, 7, and 5, 3. Okay, the slope of the line passes through these points. How do we do that? Okay, I would do this. I would actually sketch kind of a picture just so I can see what's happening and then look at the space. There is a formula for this, but I want a visual just to help myself with it. So I'm going for -3, 7. That's like here at -3, and then let's go all the way up to 7. There's a point. And the other point is at 5 and then at 3. Okay, so we're going from here down to here. And this slope has a distance that we go up and down, and then also a distance that we're going left and right. The up and down starts at 7, drops to 3. And how far is that? Well, 7 minus 3, that's 4. And the other one, it goes from -3 over to 5, and that would be a distance of 8. So it looks like I have a slope of 4 on the vertical and 8 on the horizontal. And the slope is measured, the way that we look at it is the up and down quantity over the left and right quantity, you could say. That's how we describe our slope. So in this case, that would be 4 over 8. Now because it's going downhill like this, that makes it negative. So this is going to be -4 over 8. Now, of course, on a test that's got multiple choices, they love to simplify fractions. So I'm going to think of this as -4 over 4 times 2. And the 4 over 4 makes a 1. So it's really -1/2. And there you go. That would be your answer there. Of course, you could do slope formula, and you do like y2 minus y1 over x2 minus x1. But guess what? You get the same thing, -1/2. I like to look at the visual. That confirms for me that I really know what I'm doing. All right, now we got something going on. In slope-intercept form, write the equation of the line that contains the points of the table. Well, I would love to do slope-intercept form, but I love graphing, so I'm going to go ahead and draw myself a little graph here. And let's practice this. We got -4, -9, so that's like way out here. I'm just going to do like the numbers in the middle here. 1, 2, 3, 4. And we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's just see what we got from those. -4, -9. That's like way down here. And then we got another line, or another point that's at 0, 3. That's way up here. So there's basically my line. But that's kind of convenient right here. That's my y-intercept. And for slope-intercept form, I need to know what that is, and that's at 3. So that point 0, 3 was really helpful. All right, let's look at another thing that's happening. So if I were to try and measure this slope, I started down here at -9, went all the way up to 3. And how far would that be? Well, that'd be 12. And that's kind of looking at this distance between -9 and 3. That's an upward movement of 12. Then the other movement starts here at -4 on the left side, -4, and it goes to 0. So that's a distance of 4. And that's kind of measuring my run there. So now if I were to look at this as a fraction, it'd be 12 over 4. Because we have up and down 12 and left and right 4. What would that simplify to? Well, it's positive 2, so I'm going to leave it as just 12 over 4. But then we simplify it and we'd get 3. All right, so that's my slope. So if I'm doing this whole y equals something times x plus something, the y-intercept in this case is 3. And hey, guess what? So is the slope. How convenient was that? All right, let's take a look at something else here. I'm going to change colors a little bit just because we're starting to overlap into multiple questions. It says in slope-intercept form, so that means I'm going to have to end up with something like this. No problem. I got to find something that's parallel. Okay, parallel means that they have the same incline between two functions there, or they have the same slope, which is how we measure that. So when I'm saying parallel to this, I'm really focused on the slope, which is 3. It's right there. Right there. Let's highlight that a little bit better. Actually, let's actually highlight it. Boom. That's what we want, is that 3. And it's going to pass through this point. All right, so there's a couple of things that we could do to figure this out. I'm going to try something different here. So I noticed that I have y equals 3x plus, I don't know. I don't know what the y-intercept is. But I do know this x and y coordinate are on that line. So I could plug in that x and y into this equation. That would give me the y is 4 equals 3 times negative 4, and then plus something, whatever that y-intercept is. Well, let's take this a step further. That would be 4 equals negative 12 plus, who knows? Well, if I were to add 12 to both sides, that would give me 16 equals that question mark, which is the y-intercept. So there's my y-intercept, it's 16. So now I have enough information to complete this. The slope was 3, we got that from earlier, and the y-intercept was 16, right there. So y equals 3x plus 16. All right, we're nearly done here with this little set. We're about halfway, probably a little more than halfway. Let's switch colors. Actually, we need to go back to black, I believe, here. Shouldn't be too bad. Let's see what we got. It says graph the inequality, and then we got an inequality. So how do you graph an inequality with y and x? Well, it's just like graphing an x and y graph, except now we got some shading going on. So there's some things we need to check. The first thing I checked is right here, and it is not equal. It's only greater than, not equal, which to me means a dotted border. Okay, so I'm going to use that idea. And the border line is represented by this y equals mx plus b, the slope-intercept form, which means I'm going to have a y-intercept at 2, and I have a slope of 3 over 4, which means I go over 3 to the right. No, I go over 4 to the right and up 3. So up 3, 1, 2, 3, and over 4 to the right. And I have a line that kind of looks like this. It's a rough sketch, but that's what we're going for. All right, so we got graph that inequality. And then it says y is greater than. I think that means it's above it, but I'm going to use a test point just to check. I'm going to check 0, 0, because I love 0, 0. It's like the easiest one to check. So then I would plug that in for x and y. 0 is greater than 3/4 times 0 plus 2. Well, 3/4 times 0 is 0, so that would say 0 is greater than 2. That's false. False, which means this side is false. So that means this side is true. So the top gets the shading. That's the graph that I'd be looking for. All right, let's look at this next one. We got a couple more here. Let's kind of split our space. I'm going to do number 23 over on this side. It says graph using intercepts. Well, let's see if we're going to graph it here. Go ahead and make a line, horizontal, vertical. There we go. All right, and it says 12x plus 30y is greater than negative 24. So 12x plus 30y is greater than negative 24. So if I want to graph that using intercepts, this is that thing where we kind of covered stuff up. So if I were to like cover up this 30y, that means that y equals 0, and I'm finding an x-intercept. Well, 12 times what is greater than negative 24? 12, that would be a negative 2. So if I divide both sides by a negative 2, then I would get x. Let's see if we can do it. So what I'm saying here, let's do this. I would have 12x is greater than negative 24. Divide by 12. You'd have x is greater than negative 2, which really means that negative 2 is kind of my intercept. So I'm going to go 1, 2, and there's an intercept right there. Now let's look for the y-intercept. If I were to do the same thing but make the 12x go away, I would have 30y, and that's greater than negative 24. Okay, now this one's not as easy. We have to do a little bit of approximation here. But if I divide both sides by 30, let's see how close we can get. Looks like y is greater than negative 24 over 30. Well, both of those are divisible by 6, which would be 4 over 5. And it's negative. Negative 4 over 5. So that's actually going to be, like, let's say here's 1. It'll be right about there. Now, because we have a dotted line, or not equal, this is not equal for our borderline, because that's not equal there. Okay, so I'm going to draw a dotted line here. Close enough. That'll work. And then we need to think about, is it, is it going to be true or false on which side? Which side do we shade? It's kind of hard to tell just by looking at it. But let's try testing a point. Let's try 0, 0, our favorite point to test. That would tell me that 0 times x, or 12 times 0, plus 30 times 0 is greater than negative 24. Well, 0 is actually, in fact, greater than negative 24 because negative 24 is negative. That's below 0. So that's true, which means this side is true. So I'm going to shade the side that's true. There we go. All right, number 24, we're wrapping it up here. This is like the longest video ever, mostly because there's so much graphing. So let's see what we got going on. Oh my goodness, look at all these x's and y's and symbols. Let's work out what we got. Okay, I'm going to go ahead and distribute this 5. That would give me 25x minus 20y is less than, let's go and distribute this 3 as well, 6 plus 8x minus 17y. We got lots of action. Let's take it a little further. I'm going to go ahead and add 20y to both sides. I'm also going to subtract 8x from both sides. Let's see what we got after we do those two moves. That would give me 17x is less than 6 plus 3y. All right, that's not too crazy. Let's go ahead and move this 6 over to the other side. That would give me 17x minus 6 is less than 3y. If I were to divide by 3 on everything, that would give me y is greater than 17 thirds x minus 6 over 3 is 2. So that's what I got going on. Now, how do I deal with this? Well, what do I do to kind of work through that? Well, a couple things. I could kind of flip this whole thing around. That would give me y is greater than 17 thirds x minus 2. Now it's a little bit more familiar because we got the whole y and mx plus b. That tells me that negative 2 is my y-intercept. So if I'm going to sketch a graph here, nothing crazy. That means at negative 2 I have a y-intercept. I also notice that my slope is 17 thirds, which means I'm going to go up 17 and over 3. That's a pretty tall line. And then lastly, I notice here that it is not equal to. It's not equal to. It's just greater than 2. So it's not equal. So that means that we're going to have this line that's kind of dotted and it goes way up like that, way down like that. And then you're probably wondering, oh, should I like test a point or something? It says greater than. 0, 0 happens to be on this side, but just to make sure, I want to use a number that I know is going to be on the left side of this line. So I'm going to pick, like, how about negative 3? So I'm going to pick negative 3 comma 0. That point right there. Well, if I were to plug that in, that would give me 0 is greater than 17 over 3 times negative 3 minus 2. And 17 over 3 times negative 3 is really negative 17. Negative 17 minus 2 is negative 19. And 0 is definitely greater than negative 19. So this part is true. I'm going to shade that side, and this video is done. Quick review on what we were doing here in most of this stuff. We're looking at slopes, we're looking at y-intercepts, we're also looking at true or false to shade, and all that kind of stuff. And a lot of it's just solving the equations, watching that rise over run, and then double checking your shading. Okay, so that's it for this video. Please watch it again, go through it, practice it, do it again, all that kind of stuff. And we will see you later.